we want to now actually move on to another type of monitor. Now, this type of monitor is called a flat display, also known as an LCD, or liquid crystal display monitor. And these are the types of monitors that you're seeing more and more commonly now. They use less power than our CRT monitors did. They generate less heat. They take up less space. They create less glare. They weigh less, and they actually emit a bit less radiation than the CRT monitors even emitted. So for many of those obvious reasons, we're moving more towards LCD displays in our monitors. LCD displays don't use the electron beams like CRT monitors do. LCD screens actually use an active matrix to control liquid crystals. They align these liquid crystals using an electrical field on the monitor space. So we don't have the big bulky monitor anymore. We just have the single monitor's face. We have a couple different components to these LCD monitors. We have our liquid crystal layers. We have our polarizing film. We also have our light source, and then of course the electrical field. The liquid crystal display actually doesn't provide its own light. The electrical matrix simply aligns those liquid crystals and allows the light to pass through it in a way which shows us our image. So that's why we have the additional light source. The crystals don't create light themselves. It's the additional light source which lights up our monitor, which does that. That's why sometimes we'll see a situation where our monitor may be on, or we haven't, say we have a monitor that we've used for a long time. Perhaps it's a laptop monitor, and the monitor's now completely blank all the time. And our laptop's on, it's running, but the monitor always is really, really dark, and we can't really see anything. Well, it may not be that the entire screen has gone bad, but it's actually that additional light source which provides the light through that monitor which has gone bad and which is having a problem. With our LCD monitor, we actually have, each pixel is actually 3 subpixels covered by a filter. When we're talking about our resolution, we don't just have 1 pixel across our entire monitor. As we said, each pixel actually consists of 3 subpixels which are covered by different filters, letting through little bits of that light in order to help us to change our color. Moving those filters, using the electronic fields in order to move those liquid crystals around, changing the way that we're actually seeing the color through the monitor. With our LCD monitors, they've actually gone through a couple steps in their development. 3 steps in particular we need to be aware of. Originally, we had our LCD monitors with something called a passive matrix. And some of our downsides with our passive matrix is that it was a less sharp image, and we did have some ghost images. It wasn't an active image, an active matrix like we use now, but again, it was a passive matrix. So we resulted in some less sharp images and some ghost images. Additionally, our next step of development was dual scan technology. Our dual scan technology was a slight improvement to the passive matrix. There was still a little bit of those ghost images, but it was a bit of an improvement over the way that those liquid crystal displays worked. And then our third step to be aware of, and the most common that we use now, was our TFT matrix, also known as thin film transistor. And this is going to be the step where we have our active matrix. So when you think of active matrix, think of our most recent TFT type LCD screens, which stand for thin film transistor. And that's going to, again, be our active matrix.